Thank you, Sid.
Okay, believe we can start. Hello, everyone. Good morning, good afternoon, good evening. So welcome to the 12th annual workshop on the energy efficient HPC working group. This is day one. Torsten and I would like to welcome you all on behalf of all the workshop committee organizers. We are very thankful of their input here. Some logistics, the website link should be in your email, and all the presentations, including the bios of the speakers and presenters, moderators, panelists, all of those are uploaded on the slides on the website. And here's the link to the broader energy efficient HPC working group. A few etiquettes, just a request for non-speakers to remain muted for the timeline of this presentation. All questions and answers could be directed to via the chat box during the presentation, and moderators, they are requested to please review the chat box frequently, especially during the panel sessions as we field more questions, and also during the question answer round for each of the sessions. Here's an overview of the agenda. We have 3 sessions today and then 2 tomorrow. We start with an overview of the energy efficient HPC working group by Natalie Bates. This will be followed by a panel session. For the panel session, the focus really will be on electrical system provisioning and powering of HPC systems. Focus, of course, will be more on the challenges of electrical system provisioning. Most of the electrical system topics that are relevant to HPC centers will be covered here. We also have some invited speakers on the theme being sustainability initiatives across HPC sites. Power consumption and cooling are, of course, discussed on and on again with regards to sustainability. It is still an important factor, and this particular session will focus really on some of the challenges and lessons learned. Tomorrow, we have a session on liquid cooling. And again, there, the focus will be on current trends and challenges, lessons learned so far, ongoing activities, really to enable higher power density and better energy efficiency. And then this will be followed by another invited talk session on system-wide power monitoring challenges, right? So power monitoring in general across the system is challenging, but the insights that you gain out of it, analytics learned and obtained, are highly beneficial to different HPC sites. The implementation approaches, of course, are different. So some of the lessons learned and challenges there will be discussed. Okay, with that, we are ready with the first session, an overview of the energy efficient HPC working group. Natalie Bates, of course, has been instrumental and is one of the co-chairs of the working group since its inception in 2010. So a very good overview of that will be quite helpful. And Natalie, thank you so much. Over to you.
Thank you, Sid. So I'm going to give this talk on the EE HPC working group, and I'm going to encourage you, I'm going to give you an overview, and if you're not a member, I'm going to encourage you to join and to engage and participate. Next slide. But first, I'm going to start with something a little light. So this is my cat in a box, ready for a trip elsewhere and living with COVID. This is sometimes how I feel and have felt for the last couple of years. I really miss all of you guys. I'm looking forward to the day when we can all get together and talk in the hallways and have a beer afterwards. So this is also somewhat of a joke because, you know, cat videos and cat pictures take up lots of space in our IT world. And, we probably do want to focus on doing stuff that, is more productive rather than less productive, or more worthwhile versus less worthwhile. But we'll talk about that in the sustainability session, perhaps. And finally, we've been trying to cultivate relationship globally, especially in Asia, and that's a 575 poem. So thanks very much. Next slide. Okay, now I'm going to go on to introduce the EE HPC working group at a very high level, and then give some team updates. Next slide. All right, so the EE HPC working group is global. So we do have participants around the world. In fact, we have about 800 members from more than 30 countries. It's comprised of about 50% of the members are from sites, from HPC sites. 30% are from the vendor community, and that includes all the major system integrators, chip providers, as well as quite a substantial number of the liquid cooling vendors, and other vendors as well. And you'll meet some of the people actually today. But then 20% of our membership are from the research community, academics, people that are interested in HPC and energy efficiency. What makes us particularly unique is the blend of both the facility people, facility-focused people, and HPC system people. There are quite a few forums that are tailored in energy efficiency to the HPC system community. There are fewer of them that have such a strong membership in facility and operations, as well as the HPC system. And it's free, so it doesn't cost anything, and open. Anybody can join. Next slide. What do we do? So our organization is really not intended to be a long forever kind of an organization that hosts specifications and standards and updates them. Our organization is really meant to accelerate energy efficiency and sustainability. It takes, like I said, a task force approach. So we come up with an idea, and if there are enough people that are motivated by it, we potentially form a team. The team gets together and starts to ask, what is it that we could do about this issue or challenge or problem? And is there anything that we can produce? That deliverable that we produce takes a range of things. Often it's a document, most often it's document, but sometimes it's just brown bag sharing, just get together and talk through some of the challenges. And then ultimately, we like to have it handed off. That handoff can take a range of experiences, from just, published, documented presentation material and minutes, to all the way to a document which is adopted by organizations. For instance, the Green 500 and the Top 500 use a document created actually by the EE HPC working group for their power measurement methodology. We also work with other bodies like ASHRAE and OCP, other bodies as well, but those are the major ones. Okay. All right, so these are our active teams: operational data analytics, procurement, controls, electrical systems, liquid cooling, power API. We have a web migration team, and we are convening a power measurement team. Next slide. I'm going to talk for a minute about the operational data analytics team. It's led by Michael Ott and has a lot of really great synergy. Currently, they're doing a lot of sharing of, sort of brown bag discussions, but they've also written a lot of papers. And there's some of I've included the titles and primary authors for all the papers that this team has written. The purpose of this team is to accelerate the innovation and early adoption of ODA. Go next slide. So the most recent work that they've done is a framework for ODA that we think will be helpful for the community to be able to understand where we stand, what opportunities exist, and what do I need to do as a site to improve my ODA capabilities. It starts with a 4-pillar framework made by LRZ, which has a description of HPC from the building infrastructure through HPC applications, including the system hardware and system software. Next slide. Then it takes another framework, which is really from the business community, that describes 4 types of data analytics, from descriptive, like what happened, things like dashboards, to diagnostic, why did it happen, sort of root cause analysis, debugging, to predictive, what's going to happen, so to, you know, a regression model or a simulator, and then to prescriptive, which is optimizing and controlling. All of these types are, this is not necessarily ranked by complexity or usefulness. It's just 4 different categories, and which one is appropriate depends on your business need. Next slide. So what we've done is we've combined the 2 in a 4x4 matrix. And next slide. Then we've taken all the work that we could find and we categorized and classified the literature describing all the efforts, the ODA efforts in HPC into each one of these quadrants. And so we've written a paper on this that I cited at the beginning. We also had a BOF on this at supercomputing. Both of those things are available through the EE HPC working group on our, on our public cloud material, so you guys could learn more about it. But it's a really, I think it's a very useful model. Next slide. Okay, so then the procurement team. This is a team that writes a document to encourage consideration and discussion of energy efficiency and power management during, it's of energy efficiency as well as power management during HPC procurements. Gert Svensson from KTH and Jason Hick from LANL are the leads on this. It's been around since basically the beginning of the EE HPC working group, and we've published updates to the document. Started in 2013, most recently in 2021. Next slide. The 2021 version did a deep dive update on section 4, which is usage cases for power, energy, and temperature management and control. We broke it into 3 sections, one focusing on the data center, another focusing on system software, and finally applications. They define requirements. We categorize the requirements into basic, advanced, and innovative. Next slide. This is an example of one of the requirements from the applications section. It talks about tools for energy or power optimization. And one of the requirements is that there be a power and energy consumption of the system component shall be exposed to an application. We consider that a basic requirement. And then we describe it with a potential implementation, a potential scenario, and possible actors. Next slide. Here's one which is innovative. Users shall be able to dynamically optimize the energy efficiency of an application through a specification of application/system specific tuning parameters. So you can see that there's a big difference in the relative time frame and ease of implementation of these two requirements. And so this document is extensive, detailed, and has a lot of really good information. We recommend that you look at it and use it as a foundation for discussion and consideration when doing your procurements. Next slide. Okay, cooling controls. Our cooling controls team is led by Krista Prater and David Grant. We feel that there are, and we have felt that there are suboptimal outcomes in our control systems. And these are facility-based control systems, mostly for cooling, and gaps in the design process. So we've done a variety of things, starting with, at the very bottom, with a document which describes the dynamic control data inputs for HPC facilities and systems. And we gave that to the Power API team and Redfish and ASHRAE. And several of those organizations, in fact, all three of those organizations have taken this into consideration in versions of their document. Currently, we are writing a guideline that will help data centers in their design phase of their control systems. So this is mostly focused on every time we do a major refresh to our data center, when we get our next big machine, we often have to redo our control system. So this document will talk about that design phase and how to approach it, what needs to be included, how do we communicate with our controls vendors. And it builds upon industry practices in terms of design documents, building off an owner project requirement template. Next slide. I'm just going to keep going, actually, because I only have 3 minutes left. So next slide. All right, liquid cooling. This has been an instrumental team from the very beginning. The ASHRAE WX criteria came from the EE HPC working group and was described in a paper that we wrote at the bottom, hot for warm water cooling. It's currently working on transfer fluid water treatment for closed loop hydronics systems. And that is a document which will have a couple of different forms, one of which we hope will be adopted by OCP and ASHRAE. But others will be just a guideline for people to use in their data centers as they deploy liquid cooling racked systems. Next slide. All right. This is the electrical distribution team. It's run by Grant Stewart and Brandon Hong. You'll be hearing from a lot of the members of this team today, later right after me with the panel. But you can see that this team has been around for a while too, and has written a lot of very interesting papers that we think are really useful for sites and for the community at large to describe the challenges that our very large HPC sites put on both their local distribution and their broader grid electrical, their electricity service providers. Next slide. We have had, as I mentioned, a power measurement methodology team. We have created the document that the Green 500 and the Top 500 are using, and we're just about ready to kick off that team once again and update that document. Next slide. We are redoing our website, and we're going to have sort of four thrusts: a public portal, right, and a public cloud, and restrictive collaborative cloud, and then email list. So there's 4 parts to the architecture for our web presence. Next slide. We're going to be updating our website. So the one on the left is our current site. The one on the right is what our new site's going to look like. It'll have, sliders and other kinds of things, but mostly it'll have buttons that you push on that allow you to go through to a more agile public cloud that we can update regularly. Next slide. And that'll have things that you guys are currently engaged with that I can keep current. So it'll have, web pages with very specific kinds of information that you can access real time for things like this workshop today. Next slide. All right. So I'm on the last slide basically. And I wanted to say that there are actually some non-active teams that I didn't describe. We have a lot of publications on energy and power aware job scheduling and resource management. We've done some really great work on TUE, which is another way of, it's another metric for measuring energy effectiveness. And we have quite a few papers on dashboards, as well as we've started to look at RASM, reliability, availability, serviceability, manageability. We've started to look at policies and optimization for EPA, JSRM. And finally, reproducibility. What do we need to do in this organization to improve the reproducibility of our work? And that's it. Thank you. I think I almost stuck to the time. All right, Sid, all yours.
Thanks, Natalie. Great talk. 2 questions in the chat. And a hand raised by Randy. Randy, if you'd like to vocalize your questions, over to you.
Thank you. Hey, Natalie, I just saw the dashboard. I happen to be parallel processing this morning, so I apologize. The reproducibility, which is, it's in its 5th year now at SC, the last 2 years I've caught, and there's coincidentally or adjacently some keen interest on my part. And I'm wondering, what's been going on with that? Do I need to catch up offline? Because that seems to be potentially considerable opportunity, because I was looking at some of the results and they show that in terms of reproducibility, there could be 10% waste of energy.
Yeah, thank you, Randy. You can see that we participated in a panel at SC, and that's what we've done so far. Tom Skoglund was the person from the EE HPC working group that spoke. And so if you go to the SC website, and I'll chat the link in a second, you'll see the name of the panel. That should be one of the things that was recorded and will be posted as far as the SC 21 results. And that's what we've done so far.
Okay, because I participated in that activity or attended that activity. So, okay, I'll follow up separately. Because like I say, that
yeah, thanks, Randy. Sorry, we're running late, so I'm going to cut you off. Okay, are there any other questions? Maybe we have time for one more.
I did put a couple things in the chat, maybe offline, that can be follow up.
Okay, excellent. Thank you. All right, I'm going to turn the floor over to Sid or Joe. Actually, Joe.
Okay, Natalie,
yeah, thanks.
Yep, I'll go ahead and take this.
Yep, go ahead, Joe.
Okay, so I don't know if you want to say anything here, Sid. If you do.
Oh no, go ahead. No, go ahead. I'm just flashing the names of the panelists. We are very thankful for the presence, and Joe, thanks for driving it. Over to you.
Sure, Sid. I'll need you to go ahead and stop sharing your screen so I can share. It's not letting me share right now.
Okay. It's off.
Perfect, thank you. Well, good morning, good afternoon, and good evening to everyone. I think today we have a great panel for you on electrical system provisioning and powering HPC systems. I'm going to have all 6 experts introduce themselves, and I have to say, getting to know many of those on the panel, it truly is a group of experts in this area of electrical distribution, electrical powering of HPC systems, et cetera. So with that, Brandon, please introduce yourself.
Hi, good morning. My name is Brandon Hong. I'm working at Lawrence Livermore National Lab. I'm a design electrical engineer for the Livermore Computing HPC group.
Good, thanks, Brandon. Grant?
Hello, Grant Stewart from Los Alamos National Laboratory. I work in utility operations, and I'm project director for some of our power upgrade acquisitions and a strong supporter of our HPC program at LANL. Thank you.
Good, thanks, Grant. Herbert?
Hello, my name is Herbert Huber. I'm working at Leibniz Supercomputing Center, and I'm the department head of the High Performance System Department, which operates all supercomputers and all large storage and server systems at LLNL.
Good, thank you, Herbert. Christian?
I have to unmute. Hello, everybody. Yes. This is Christian Blug from Siemens in Germany. I am an electrical power engineer at Siemens for more than 20 years. I'm actually a principal key expert for power quality analysis, and I'm dealing a lot with power quality studies, especially for data centers. Thank you.
Good, thank you, Christian. David?
Hello, my name is David Mohr. I'm a distinguished engineer with NVIDIA, focusing primarily on rack level power out through to the grid.
Perfect. Okay, thank you, David. Ethan?
Ethan Thomason with Primary Integration, Bureau Veritas, specializing in commissioning of data centers, resolving issues with electrical distribution inside and out to the grid.
Okay, good. Thank you, Ethan. Because of time, we will jump right into it, but you can see based on introductions, a wonderful panel of experts. I have 3 questions. I doubt we'll get to all 3, but the first one here is the most important, and it's probably the most long-winded, but I'll go ahead and read it. One of the challenges with the electrical design of any data center, especially HPC, is provisioning the electrical system. Over-provisioning may lead to stranded electrical capacity and may result in unnecessary capital expenditure to support the projected demand. However, under-provisioning, when demand exceeds capacity, can be disastrous, resulting in overcurrent protection activation and downtime or safety derating violations. So the question to the panelists is, what design principles, design strategies, and equipment specifications should be used to successfully provision an HPC data center electrical system? And what I'm going to do is I'm going to start with the panelists in the way I introduced them. So Brandon, please give us your view.
Thanks, Joe. So yeah, over at Lawrence Livermore, for our latest upgrade for our future exascale computers, we have 2 coming in the next 10 to 15 years, but one upcoming very quickly. We started planning on how to maximize the upgrade that we're doing currently. We're upgrading our existing facilities from about 45 megawatts to 85 megawatts total, and we want to be able to maximize that full capacity. So one of the things I'm doing for the future, or the next upcoming system, El Capitan, is to anticipate the maximum load, but also knowing that after the peak load is ran, and also like LINPACK is ran on the system, and these systems are only going to be using about 60% of their actual designed peak load. So what I've been doing is installing provisional spares, available space in switchboards as well as panel boards, as well as I think it's important to have metering and sub-metering on each of these pieces of equipment. And that way you could add future loads onto these after they're into their general use stage of their life.
Okay, very good, Brandon. Thank you. Okay, Grant.
Yeah, thanks, Joe and Brandon. At LANL, I'm going to just give you some perspective from the utility side. We as our mission grows and our HPC load grows, of course, it taxes many of the external distribution and transmission systems that we operate. And so one of the things that we spent a lot of time focusing on is the thermal verification of the underground feeder circuits and the combined duct banks. that turns out to be quite limiting if you're stacking too many circuits and you don't have the right thermal properties for your soil. And if you have an HPC system that's going to run a LIN pack or some other major stressor power demand event, if you do that in the cold period, you have less impact on those feeder circuits from a thermal standpoint. They can tolerate more. That's kind of interesting, I think. And we've spent a lot of time recently focusing on our making sure that we understand the operational readiness of capacitor banks and the switched variety that are necessary to maintain a unity of power factor on the distribution. As the supercomputing power ramps up and down, this provision minimizes the voltage disturbance from that kind of activity. And we've strived through dynamic power flow modeling to better understand the role and importance of our on-site generation and static VAR compensator that we have on our transmission voltage system. These are automatic voltage control devices that are very important to power flow stability in the growing HPC realm. So a lot of work there, and it's really several different kinds of models, and they all have a niche and a purpose. So that's been a major push for us. And then of course we're spending a lot of time on improving our system response through smart relays and sectionalizers, and trying to get to a power distribution system that has less physical redundancy, but still reliable because of the smart switching capability. So I could go on for hours. I love this topic, but thank you, Joe. There's a few ideas to share.
Yeah, perfect, Grant. Thank you. Yeah, I know there's a lot of thoughts on this topic. So next, I'll move to Herbert.
Yeah, thank you. We'll be able to start the procurement of our next supercomputer soon. And what we are asking our vendors is always the maximum power consumption of the supercomputer running HPL and the idle power consumption of the system. Because as you know, the energy efficiency features of the novel processors, so unused units of the processors are shut into a low power mode. And if the processor is doing some I/O, all processing elements are more or less, or most processing elements are turned into a low power mode. And if you have a highly tuned application, which does MPI I/O during some portion of time, and then uses a very highly tuned phase where all cores are active, you can have a difference in power consumption of the systems in the order of 4 to 5. So for a 20 megawatt system, the idle power consumption is in the order of 5 megawatts, and then within some milliseconds, the power consumption goes up to 20 megawatts for this kind of applications, if the application runs on all compute nodes of the supercomputer. So that's a problem. And that's also a problem for the power provisioning company. So for that kind of reason, we need a new substation, because otherwise the lights in the campus of Garching will go out, and also the lights of the city of Garching will be turned out if we run such an application on our next supercomputer. So it's really very important to know the maximum power consumption of a system running HPL or highly tuned applications, and also to know the idle power consumption. And then you know the step in power consumption highly tuned application can cause. And so that's a very important impact, and you should know about that impact. If you provision your site and also your power. If you have a power company, you need to know this kind of effects, or let the power company know this kind of effects, because this kind of behavior has not been able to be observed in the past, that the supercomputers consume more or less the same power, no matter if they have been in the idle mode or fully used. So with the modern supercomputers, that's really, really different. So, and that's in my mind, the most important thing to watch and to think about if you design the electrical distribution for a new exascale system.
Yeah, Herbert, thank you. Excellent points there. Basically finding the upper bound of power and the lower bound. So you have this envelope of where the power consumption will be. It'll be either at the bottom, the top, or somewhere in between. So Christian, your thoughts, please.
Yes, so Grant and Herbert have mentioned already most of the aspects. So normally the reliability of supply is the most important design principle. But as Herbert already told, in our special case, power quality is even more important. This would mean that the center should be immune against power quality issues, but even more important, the computing center should have a low impact on other consumers with respect to the power quality. And what is also very important from my point of view is to early contact the grid operator, because it's very important also to announce the long-term load forecast for it. Because as we can see, the load density, but also the overall load of data centers are increasing from year to year. And so you should be able to connect the additional load also to the public grid. And therefore, you don't need only the maximum load today, but you need also the load volatility and the maximum load tomorrow in the long term. And this must be communicated to the grid operator. So load forecast is important, and from the commercial point of view, the structure which is defining your grid structure should scale with the load, so that you have that you are also running your structure in the most cost-efficient way.
Good, thank you, Christian. Very, very good response. When I think about power quality, which is a very important input, I think of IEEE 519 dealing with harmonics, voltage fluctuations. Also, I think of EN 5160 that I see referenced in a lot of standards regarding power quality and what needs to be met by the utilities in Europe. So thank you. So David, your thoughts?
I'll try and keep my thoughts a little short because I think the previous speakers have covered it very well. Being able to accurately predict the performance and the power required by the system in order for the users, the data center design, and the utility to be adequately sized to be able to get the maximum out of that system. It is a delicate balance, and I think a lot more focus needs to be done on accurate modeling, really from the chip out, so that we can fully utilize the systems we're building.
Yes, yeah, great point, the modeling. And I know Randy's on, and I know that's one of his favorite topics is the modeling piece of it, and things like digital twins, to be able to go ahead and create a model of it and then, validate it with measurements. So good, thank you. So Ethan?
So I'm more on the implementation end, but really understanding what the loads are, how the loads operate, trying to figure out what factors people have included in their information. So make sure that people haven't oversized their requirements because they want to make sure they have a safety factor, and then the engineer on top of that puts in a safety factor. So make sure everybody's is aware of the safety factor that they're being built into the system. Understand the capabilities of the equipment that's being supplied. A good example is 80% rated breakers versus 100% rated breakers. And then, how the system, the power is going to flow through the system. And specifically with the cycling, a lot of the data centers are just tested to full load capacity. This new thing that we're working on with fluctuating power levels is not something that's typically tested in a typical facility commissioning program. So trying to mimic the actions of the load to make sure that we have, we wring out all the problems before the supercomputer is installed.
Okay, yes, yeah, thank you, Ethan. Yeah, great points made. And it made me think, even though I'm the moderator, I was thinking when you were talking about those that deal with data centers and they still use the rating label on the product for sizing the load. And I try to encourage people who do the sizing for loads to try to get a maximum measured power consumption value for their specific configuration. Because a lot of times you'd have a rating. I encourage people to use that for their electrical service planning, to know that, let's say I have a 24 amp rated rack PDU. I'm going to put it on a 30 amp circuit breaker if you have to apply the derating of 80%. If you have a maximum measured power value, a lot of times I see in specifications, it's the maximum for a system with its largest configuration, highest utilization, and it's a more realistic value, but what you really need is the value for that system as configured. And I know I get challenged a lot in the co-location in cloud spaces on that.
What about the stuff Ann brought over?
All right, someone needs to go on mute. What I'd like to do now is open this up to any questions about provisioning before I move to the next one. I would encourage you, if you can, just to go ahead and open your mic. You'd be free to put it in the chat as well too, but I think a discussion would be great. Any questions from the audience? Okay, well, hearing none, then we'll move to question number 2. And these are the questions I like, the what if, right? When they're barring no challenges whatsoever. So here's question number 2. If you had the freedom to do one thing differently to improve any aspect of the electrical design of HPC systems or the HPC facility electrical distribution, what is that? So again, I'm going to go to each of the panelists and ask them for their views. So I'll start again with Brandon.
Yeah, ultimately, the greatest freedom would be nice. It'd be nice to have a brand new facility for the recent or the upcoming systems. The facility I have right now and is built in 2004 and is planned for about 15 megawatts of power. And now we're upgrading it up to 85 megawatts. And it's going to have its own dedicated switch yard, high voltage switch yard. And really, I'm running out of physical space. And we have all the capability electrically, but physically, it's been very demanding. I've reused underground conduits. I'm now having to run things overhead and exposed, and with a downstairs mechanical space and the computer room upstairs. The downstairs space, I'm putting in about like medium voltage 13.8 kV downstairs. All that transformers, switchboards, it eats up everything and all the large conduits, and that leads into issues with available fault currents being very high, and having to have current limiting devices that help limit that. So everything takes up more space. That's one of the issues I have right now.
Yeah, that's a great point, Brandon. I mean, I guess you think about, electrical, but outside of that, yes, these cabinets, right, house more power and you need more of them for the parallel processing. And then all the switch gear, obviously bigger switch gear takes up more space. So yeah, excellent point. Grant, your thoughts?
Sorry, had to reach for those buttons.
No problem.
Yeah, I would say, I don't know, maybe this is a little bit out of the realm of what you had in mind, but it as Herbert described, the kind of growing impact on a modest sized system of the highly dynamic load. What we've seen historically in industry, like for smelters and arc furnaces and other highly variable demand, they're forced off the grid and they're forced to provision for their own power generation. And so, it would make sense for me, for in my imagination, to think about an HPC that's more of a standalone facility, at least for the compute load, maybe not so much for the facility load, but the compute load would have its own power generation that can ramp with the kind of capability that we've been talking about today. And I have a preference, I'm a leaning for hydrogen-based generation and storage. So I think the future supercomputing facility with its own sort of hydrogen generating fuel supply could be a positive contributor in the grid setting rather than one that challenges the system performance and power quality. Thanks.
Yeah, thank you, Grant. Yeah, interesting perspective when you start talking about fuel cells and things like, hydrogen. I've seen others that are trying to use natural gas. So we'll see what the future brings, and it definitely ties into sustainability. So yeah, excellent points. Thank you. Herbert?
Yeah, it's very simple. I would and will procure a system with power supplies with an autonomy time of more than 200 milliseconds, because this kind of power supplies will make the very steep increase in power consumption of the system flatter, which helps also the utility provider. And yes, LSZ is also thinking about producing its own energy with fuel cells, with hydrogen-based fuel cells. But that's a future perspective. Thank you.
Right, good. Yeah, thank you, Herbert. So basically a slower ramp, and I think you said 200 milliseconds. So I guess in Europe that's 4 cycles. So that definitely would help instead of having something that occurs on a half cycle or over 1 full cycle.
Exactly. Yes. Yep.
So Christian.
Okay, so I want to change the perspective. For example, if I would be a distribution or transmission grid operator, what would I appreciate to be implemented at a HPC system? And the first thing would be more load balancing. And this is more or less the same what Herbert is also mentioning. Let's say storage devices, which would be able to flatten the consumption curve. So load balancing is very important for the grid operator. The next thing is also the power quality, and the grid operators want to have a stable voltage. They want to have, let's say, a minimized impact on the overall power quality, and this would mean additional devices to stabilize the voltage, for example, static VAR compensators or even dynamic voltage restorers, which are able to flatten the volatility of the voltage. Okay.
Yes, good. Yeah, thank you, Christian. Yeah, load balancing, I know what I believe most HPC facilities, if not all, will use 3-phase power, whether it's Delta or Y. You're absolutely right about balancing for not only utility, but also for those that are using UPSs, so you don't overload an inverter in a line, right?
Exactly.
Okay, good. Yeah, thank you. Thank you. All right, David.
Again, I really agree with some of the previous panelists. supplementing the energy source either with hydrogen or some other alternative energy storage to help smooth out what the grid sees from these systems. And I would wrap that up with I'll call it a more intelligent power system in total, being able to have the system self-monitoring, perhaps reporting back through some type of control mechanism to assist in adjusting the load or helping to predict when these loads are going to be, increasing, decreasing, a higher level of knowledge of what's going on throughout the system will help us with that control function, and to really provide the load that the grid providers, I'll say, are more capable of dealing with. The dynamic levels that we're at is just very difficult for them to adjust for.
Right. Yeah, excellent point, David, about their predictive analytics and controls. Yeah, good stuff. Good stuff. All right, Ethan.
So the one that I thought of was if you're building in phase construction or you're building in planning for future growth, really make sure you've got the hooks in your system to attach and build out that future growth, and think about how that next phase is going to be built, or how you're going to test it. I was involved in one HPC that they missed the boat on part of their scheme, electrical distribution scheme, because they only built out half the system. When it came time to build out the other half, it was really quite a chore, and it became a impact to construction, impact to operations, to try to implement and test the other half of this system. And if they'd spent the extra millions of dollars up front, they could have saved themselves tens of $millions a couple years later. That's a hard thing to justify, but in this case, it really, hindsight being always being 2020, it would have made sense.
Yeah, that's a great point, Ethan. Again, when you're speaking, I think of road construction, right? They patch things up, and if they spend the money up front to do certain things correctly with the roads and bridges, they would save so much money later on. And it's true in a lot of different aspects. At this point, I do want to ask either Sid or Natalie. I know there's things in the chat. For some reason, I can't open the chat. Do one of you want to take a look at what's in there and see if there's any questions before we move on to the last one?
Thank you. That's great. Yes. I did want to make sure, Sid, sorry, I do want to make sure that we ask the question that Jeff Broughton brought up. And I wanted to ask it of David in particular, if he has any insight on answering Jeff's question. David, I don't know if you see it, about vendors seem to calculate system power based on the max TDP of processors. Has there been any work on determining what the average TDP of provided processors?
Short answer to that is yes, there is. It's a combination of the power capability of the processors or GPUs versus the cooling. There's a power profile when you look at average and maximum or peak. A lot of these things then to kind of fold into Kevin's question. So yeah, those are characterized. Cooling of those devices does come into play. There is a level of monitoring available on many systems. Part of the challenges there will be sampling rates of some of those power detection circuits. How fast can we get that information out? What is the accuracy with some of these large DIDT, workloads? So in general, yes, there is work towards that. A lot of times when sizing, particularly the peaks, are difficult to truly characterize. I've had a couple of examples through my career where a supplier will go through and they believe they've come up with the software, firmware, hardware settings to find the peak. And then, someone comes up with a different algorithm, different set of control functions, and, they can get more power out of the same quote unquote solution. To me, that goes back to the comments that I've been making throughout this conversation. Being able to accurately predict the capabilities. We need more of a closed loop model on, the design of that silicon, first characterization, all the way through deployment of these systems, and then the ability to go back in and, have customers, particular to NVIDIA, customers providing back to us, what their power levels, what they're seeing with their particular workloads and how they're configuring the system so that we can use that information to fine tune our predictive models. So it's not only a supplier customer relationship, it's got to be a closed loop on providing information.
Yeah, excellent point. So Natalie, is there anything else in the chat? Any questions that should be asked?
No, nothing specific yet. Thank you.
Okay, good. All right, thank you. So what we'll do, we have about 10 minutes left. We will actually move on to question number 3. And while the question seems really simple, what voltage is preferred to feed the HP systems and HPC data centers, there's a lot of implications to it because North America, we have 120, we have 208. We have the European Power North America, which mimics European distributions now showing up. We have 277/40 volt feeders that are available. In Europe, I know it's mostly 400 to 30, but maybe the next level above that, which I don't know offhand what that is a potential use, and there's advantages and disadvantages using different voltage levels. So what I'd like to do is give each panelist a couple minutes to give us their thoughts on question number 3. So again, starting with Brandon.
Yeah, so our original data center used 208, 120. Everything is pretty much transitioned over to 480, 277. With our switch yard, I know we have 115 kV coming in. It's basically maintained and owned by our LC group, and from there go to 13.8 into our building and up to 480 on the floor. But obviously, storage racks, network racks will all still be at 208 our site.
Right. Okay. Good. Thanks, Brandon. Grant.
Well, I can represent the utility perspective. The expense of higher current on bus work and higher voltage, is the protective measures that are necessary to operate, to be working around that equipment, and the arc flash protections that are necessary. And you have to balance that with what space you have. And, as the power grows into the 20-30 megawatt range, you're going to have to bring your medium voltage, 15,000 volt kind of range closer and closer to your facility. I know Brandon's doing that. So you're getting into the unit substation, either right outside your facility or even within your facility, and you have to deal with all the safety aspects of that. And the operability, maintainability too. You can't work on, you can't even close switches without doing some circuit balancing and load shifting sometimes at these higher power flow levels. So, you know, you really have to think about your circumstance and your trade-offs. And I would say there's no perfect answer for all situations. But from, you know, we're certainly serving everything into the facility at 480 volt, and right outside the facility, it's 13.8 kV transformer and switchgear right adjacent to the facility, and several of those kind of switchgear. Thanks.
Right. Yeah. Thanks, Graham. Two important points: the arc flash and the fault current. Definitely important. So I have about 5 minutes left. I'm going to go. Should give us a chance to go through the last four. So Herbert, your thoughts?
Yeah, very short. We currently have 15 kV transformers in the building, and they transform the voltage from 15 kV to 400 kV, and it's three-phase current. And this will also be the solution for the extension of the building. Thank you.
Good. Thank you, Herbert. Christian?
We see development to higher voltages. This would mean reduce LV distribution as much as possible. Then to connect IPS systems to MV instead of LV. And especially in Europe, where we have different MV voltage levels, then let's say 20 kV is favorized instead of 10 kV due to losses and power quality. And for powers, which are total powers, which are, let's say, higher 25 or 30 megawatt, then one should consider a high voltage connection. This would mean the connection to 110 kV via step-up transformer. Okay.
Good. Yep. Excellent question. Thank you. David, any thoughts on this one?
Agree with the previous panelists. Bringing in the highest voltage, you know, at the site level, with the fewest number of transformer or conversions down. Generally, with the available systems, you know, storage and some of the networking being usually the limiting factor. You know, trying to push everybody towards at least 240. You know, certainly 120. You know, for these types of systems is not something we should really encourage anymore. Push everybody to 240, 277 for larger clusters does help, but that has its own, you know, the arc flash and some of the other, you know, availability of common connectors, things like that become a limiting factor. So for me right now, I would say 240 is the best of trade-offs at the row level, and then get to your grid voltage as fast as you can.
Right. Yeah, good point, David, because I know once you go above 250 volts, then you can no longer use the IEC 320 connectors, C13, 14, 19, 20, those, and it does make it a little more challenging to find the right connector, and the power supply design with the capacitors and inductors have to be sized appropriately.
Yeah.
Again, once you go above 250. So last but not least, Ethan.
You know, I'll speak to the commercial world. Commercial world's gone predominantly to 230, 240 volt single phase. So the, you know, distribution into the data center or the IT room is either 480 step down in PDUs to 400 volts 3-phase inside the IT room. And then, you know, it's a question of if you've got UPSs, you know, the UPS is putting out 400 volts or are they putting out 480 volts? And that's where all the commercial people have gone.
Right. Excellent point, Ethan. I've seen that as well, because I deal a lot with the commercial too. So thank you. So with that, we have about 1 minute left. Natalie, is there any other questions in the chat?
Yes, there is. Does this closed loop idea that David brought up mean that having real data from operational data centers would be a benefit for the community at large?
You caught me. I was just typing a response to that while others were talking. Because we're limited on time, I'll try and keep it very brief. From my perspective, the collaboration or the sharing of information might be more on the lines of capabilities. I'll use random numbers. If someone has a chipset that was predicted at, a 500 watt peak, and someone comes up with a particular set of settings that can get 700 watts out of it. Maybe they do something a little different with the cooling, liquid cooled enabled, things like that, different temperature settings. Going back to some type of forum like this to say, here's how I tweaked it. Here's the optimizations. Here's the extra power I was able to get out of it. Sharing to that level might be acceptable. Not everyone is going to want to tell, what their secret sauce is. But, at a generic level, I think a little bit of sharing could help everyone.
Right. Yep. Excellent. All right. Well, with that, since we are out of time, I want to thank the panelists, for their participation. As you can see, a great bunch of experts. It's really my pleasure to work with them on our electrical distribution team, and thank Natalie for all the coordination she does, because there's a lot that goes into this EHPC working group. So with that, I will return control to Natalie or Sid. Thank you very much.
Hey, thanks, Joe. There is one other question by Randy, and I guess, Randy, perhaps if that could be taken offline due to time constraints. Sorry, we have to move on along. Thank you for the question, though. Okay, so very quickly, next session is on sustainability of HPC Computer Halls. Just sharing the screen here, just so that we can capture the panelists and the speakers. This is a speaker-driven talk, really. Thank you to the speakers for offering to give your talks. And Gert, are you online now? Or
I'm certainly online, yes.
Great, Gert. Over to you. Thanks. I'll let you take over the screen share.
Okay, so maybe I should start with saying who I am. I'm Gert Svensson, and from the Royal Institute of Technology in Sweden, where we are running the Center for High Performance Computing. And I've been interested in sustainability for a long time, I should say. So can you please mute yourself if you are going to speak? So the first speaker is John Elliott, who is Chief Sustainability Officer at Lawrence Berkeley National Laboratory. And we will listen to him when he talks about sustainability and cooling. So please, John, you are prepared to speak?
I am, and it looks like I cannot start my video. Should I share my screen, Gert?
Sharing the screen is good if you have slides.
Yep, I'll do that. Great, well, nice to be here this morning. And I was asked to speak about sustainability approaches that I think have been working well here at Berkeley Lab at NERSC, the National Energy Research Scientific Computing Center, specifically in the operation of high performance computing cooling plants. And so I was going to touch briefly on three approaches. These are general approaches rather than technical measures. The first has to do with teamwork. So an approach to establish an HPC efficiency continual improvement team. The second is to build up appropriate tools for ongoing monitoring analysis of your plant's energy and water performance. And then the third is stepping back and looking at institution level success. So incorporating those specific efficiency efforts in HPC in a broader institutional framework that promotes management support, rigor, and persistence of savings. So first, a bit about our team. So we have had efficiency optimization team at NERSC that's been meeting regularly since the fall of 2016, just focusing on continual improvement of energy and water performance. So this team involves a broad range of stakeholders, of people knowledgeable about the mechanical systems and also interested in them across the organization. You can see this little bubble diagram. You could imagine and fill it in for your organization, but at our site, it involves folks from NERSC, applied researchers from our energy technologies area, people within my organization in sustainability, facilities management, and we also have support from a consultant. So what this just really does, this regular meeting, establishes a framework for us to share expertise from our different perspectives. This allows us to gain a common understanding, a common vocabulary for talking about the systems. It builds trust. I think a big part is just being able to convene all the decision makers at one time so that we can easily make a decision to move forward, for instance, with the sequence change. We also have a convened group that can look at efforts, tools that we make and provide feedback so that we can incrementally improve those. We're able to stay on top of all the system changes that are always occurring. And of course, we're able to capture and maintain savings, which I'll talk about. Here's the group that has been involved at NERSC. It's a good looking group, but most importantly, it's a very talented group. So a lot of it is just about convening these people and sort of organizing the efforts a bit. And you'll note Jeff, Norm, and Steve, working group members there at the top. So a little bit about the savings that we've been able to generate. So I would think this is considered to be a very good facility. It was a new facility where we started work, in many ways exemplary, evaporative rather than compressor-based cooling, direct water to the chip. But by focusing on this continual improvement, we have been able to generate significant savings, about 42% of that non-compute overhead load. And you can get a sense of the magnitudes, but also the different types of measures. So the first is an example of a hardware-based measure enabling energy saving mode for UPS. A lot of what we're doing in many cases is looking at the sequence during different outside air conditions and optimizing that sequence so the appropriate and lowest energy consuming portion of the system takes the lead. At 4, that's a retrofit, so installing a new heat exchanger and generating pressure drop. And then we have also crept into the compute side a bit, and so we're doing some modulation of the Cray fans as part of the cooling system in relation to the cooling towers. So a little over 2 million kilowatt hours a year of savings and 500,000 gallons of water savings. I'll note that as we did this, while these systems are well instrumented, much of what we did was very manual, pulling the data out of the systems, crunching that data in spreadsheets, doing regressions. And so over time, we focused a lot on pulling that one-time analysis into ongoing operational systems. So that analysis is always being done and we can just focus on acting upon it. So we started at the highest level, seeking to put a real-time PUE calculation in place. So that involved looking at our metering network, understanding where we had gaps, determining whether we needed to replace any meters or add any meters. We've built up, we did a lot of data integration into the NERSC systems, but also used a general data analytics platform called SkySpark, where we have an ability to calculate average PUE over any time interval. So this is monthly average PUEs. PUEs, generally a little bit below 1.1. And then just to note that things are never quite easy. As systems evolve or you have data quality problems, we have a lot of different formulas that we can use to calculate PUE, some more or less sensitive to data quality. So we built up a framework for applying different formulas at different time periods over time to ensure that we get the most accurate PUE calculation given the available data. But of course, it's more interesting instead of an average PUE to look at it in other ways. And often how we're looking at these data are in these scatter plots. where outside air wet bulb temperature is on the x-axis and our metric of concern is on the y-axis. So you can have a baseline of operation that we're comparing against, that's in the teal color, and then a performance period in red. So we'll often calculate a 95th bin percentile as the way just to establish a threshold. So if we see performance that's outside of what we've generally seen in the past, we'll go and investigate that. And we have this for many different metrics. So this is high-level PUE, but in this case, this is looking at all of the power-consuming elements of the cooling plant. So you can generally see, probably the issue is in the dark purple, in this case, a closed loop pump. And I'll note too, as we've built up these tools, we also have developed an approach to using them. So we do have this documented script that we go through, and we do this formally on a monthly basis. We'll start at a high level in the system, move through each of the components, and determine if there's been a deviation from expected performance. And then if we see problems, we'll document them as deficiencies and then follow up on them over time. Great, so we've gone through team and tools. We're doing this quickly. And the last is kind of institution level success. And I'll touch on kind of management support first. As we do this work at NERSC, and I speak to my management, I think they fully understand the strategic value of being leaders in energy efficient high performance computing. But often I'm not speaking to them specifically about the technical work at NERSC. I'm packaging up in a broader strategic effort for the site. So this is something that I share. We update on our website every month, and I share with management quarterly that describes our efficiency savings portfolio. So we're generating savings from different areas, whether it's retrofit projects, whether it's this optimization in the NERSC systems, optimization in our general building stock or in new construction, and then rolling this up. So this portfolio that we actively maintain is now generating over $1 million of annual utility savings. And so in presenting it this way, this sort of, I think, engenders management support. They understand that the NERSC effort is a significant part of this and is important, but I think by putting it in that broader framework, it also helps ensure ongoing support of what we're doing at NERSC. As well, there's another institutional approach that we've been using, which is to certify all of our energy and water management activities against ISO 50001, so the International Energy Management Standard. I've really found that this is a good framework that really helps our activities in general be strategic, effective, and persistent. So in general, it's pushing us to be, I think, more rigorous than you might be naturally, improving our documentation, helping us to make better and more maintainable processes. And then, as I've mentioned, it also helps management understand and provide support to the effort. And I will say that within the ISO 50001 framework, there's a concept of significant energy uses that get more scrutiny. And so on our site, NERSC is that significant energy, and we also do this for water too, significant water use. So it's a good framework, I think, that helps ensure persistence over the long run, recognizing that efficiency isn't just going after a little technical problem, but it's a whole suite of things for management support, documentation, training, and so forth. And those are important for ongoing persistence, let's say over a decade. And we've been certified since September of 2020. So those are my general comments. Thank you, of course, to NERSC. And I'm happy to pass it off to the next speaker or take any questions.
Well, we had one question in the chat, and that was if you were sort of certified with ISO 50001, and you are.
Yes, we've been certified since fall of 2020 and just did an annual recertification.
But we have, I guess, lot of questions here. I have a question as well. You mentioned that you don't have so much data from the metering uptime sometimes. So you, as far as I understand, you can only calculate your PUE maybe a fraction of the time. Was that correctly understood, or?
Yes and no. So yes, so we have formulas that are, let's say, the most stringent and the most accurate, and that are using all available metering. But there are times when all of that metering isn't functioning properly. So we've developed kind of a suite of formulas that are more or less robust. So we have other formulas that maybe don't require all of the metering to be working properly. But I'd say in most cases, it's all very accurate because we can define the boundary conditions of the calculation. So the basic point is that I guess I wouldn't assume that all the metering is going to be perfect all the time. And so we're constantly working to stay on top of that metering data quality. But I think always doing a decent job of calculating that PUE.
So we have a question from Jim Rogers. He's talking about PUE charge. There are some scattered red dots. Are those periods of lower system HPC load, perhaps maintenance or similar, where the math does not benefit from system load?
Yeah. So those, in that case, those particular points that were outliers, they were maintenance type activities or changes in the system. In fact, it was a maintenance activity, and then when they moved it back, the system did not reset properly. We do have a filter where we define the operating range so that we can filter out, if the system goes down to, is basically being turned off or turned very low, and that allows us to not have kind of scatter that's not valuable in the analysis. So it's a good point, Jim.
I think we need to continue so everyone get a fair chance to talk about what you like, and maybe we can some additional questions at the end if time permits.
Sure.
John, that was a great chart, by the way.
Thank you.
The PUE chart. It's very, very helpful, right? A lot of people, I mean, we should all be generating that same chart.
It is, and it was a good talk as well. So thank you so much, John. And the next speaker is Cate Berard from the Department of Energy and lead for this sustainability there. So I think that will be a quite interesting talk as well. So Cate, you are prepared to start?
Yes, and I'm going to go ahead and share my screen. Can you see my presentation?
We can, thank you.
Wonderful, thank you so much. So I am Cate Berard. I am with the U.S. Department of Energy. I am our team lead for sustainability in our Office of Environment, Health, Safety, and Security. So we are responsible for ensuring that the internal operations of the department are done in a sustainable manner. So we cover a lot of different work, including electronics and data center management in order to make them more sustainable. So today I'd like to give a really quick overview of why we care about data centers, both broadly, globally speaking, but also within the federal US government and also within DOE specifically. And in addition to that, I'd like to extend an invitation to participate in a working group on which I think a lot of expertise that is in this group might be well used. So with that, I wanted to touch quickly on the climate change impacts of the electronics industry as a whole, and then data centers specifically. So according to the World Economic Forum, the electronics industry is one of 8 global supply chains that account for more than 50% of global carbon emissions. So it is one of those spaces where we can really have a significant impact if we focus on it. And you can see from this pie chart that even within the electronics industry, almost 50% of the impacts can be attributable to data centers and the operation of data centers. So we're talking about one of the most impactful industries, and then within that, one of the most impactful pieces of that, which is data centers. I think it's important to recognize the difference between embodied carbon, which is carbon emissions that are associated with the production of an item or a service, and operational carbon, which are carbon emissions and other greenhouse gas emissions that are associated with the actual use of the product or service, because that can tell us where we really should focus our efforts. And in the electronics industry, that can vary widely depending on what you're talking about. So these charts show that fairly stark difference between a rack server and a smartphone. So you can see that for a rack server, the vast majority of the greenhouse gas emissions and the carbon footprint are attributable to the actual use of that server over its lifetime. The amount of greenhouse gas emissions associated with the production of that server is relatively low. But if you compare that to a smartphone, a lot of the carbon footprint is embodied in the production of that smartphone, and relatively little occurs during the use of the smartphone, so charging it and things like that. So if we're talking about data centers, we're really talking about what are we doing when we operate data centers. And it certainly is helpful to buy more sustainable products and handle them appropriately at end of life in order to ensure sustainability and reduce the carbon footprint. But if we really want to make a difference, you really need to look at those operations. So that's important to the US government for a variety of reasons, one of which is that we have a very clear mandate that was put forth in an executive order that came out earlier this year about tackling the climate crisis at home and abroad. And it essentially does many things, but one of them is to direct the federal government to use our contracting and procurement power to address the climate crisis and to really look at every sector of the economy. How can we move all of the economy towards net zero emissions? How can we leverage federal procurement power to do that? And what do we need to do to focus our efforts to make this happen? So that's resulted in a significant amount of work looking at what is it that the government procures and how can we better procure that to address these issues. And that's important to DOE, not only because of this executive order, but because we have some very real impacts that have been the result of climate change. These are some of the more significant ones that have happened in the last 20 or so years at some of our sites. And you can see there's millions of dollars in damages here that have impacted operations, have impacted our budgets, and have really impacted our ability to meet our mission. And they come from a wide variety of changes. So wildfires that have occurred, 2,000-year flood events and intense hurricanes and rain events. Also the giant Texas freeze just this past year actually impacted one of our plants that had to shut down. So the effects of climate change are very real at DOE sites, and I think very real at many places across the globe. So we have an impetus to really take some action. So there's a number of things that we are doing. We are, of course, participating in this group and have been for a long time. We participate in a lot of interagency groups to help make this work go forward. I'm actually the chair of the Federal Electronics Stewardship Working Group for the US government. And there's a lot of focus on what it is that we can do, both in the data centers that we own and operate, including our high performance computing data centers here at DOE, but also in the cloud services that we procure, because a lot of our data center work, not necessarily the HPC work, but other data center work is being moved to the cloud. So with that being said, I have some slides here that are from the Global Electronics Council, because I'd like to offer an invitation to the folks on this call to participate in this initiative, because I think the expertise here would be well used in this group. For those of you that are not familiar with the Global Electronics Council, they are an organization that is focused on making sustainability the way that we operate when we do anything involving electronics, data centers, or IT services and products. they're most well known for their electronics eco label, which is called EP. And there's the most globally used eco label for things like computers and servers and cell phones. But GEC also does a number of other pieces of work outside of their eco label to try and further their mission. And one of those things that they are launching now is a sustainable cloud services initiative. So they are looking to pull together a group of stakeholders to develop metrics on what a sustainable cloud is. So there's a lot on this slide. I'll highlight a few things. GEC really wants to bring together purchasers and providers, and that's something that GEC does in general as part of their mission. That's why they have an eco label, to make it easier for procurers or purchasers of products and services to find IT that is sustainable. And so what they want to do is develop common metrics for cloud service providers. These would be sustainability metrics that providers agree that they can provide information on, and for which purchasers can use when they are procuring cloud services, excuse me. They want those metrics to be transparent. They want them to be easy to use, and they want them to be consistent, because right now we could put a lot of different things into our purchase orders when we procure something, but it would be nice if everybody agreed on what we should all use and how we should measure those things. So GEC is convening a working group of both providers as well as people who would support providers and people who procure services from providers. They are collecting volunteers for their working group members right now. Anyone can join. The point of contact there at GEC is Ben Levin. His email is at the bottom of the slide. We're looking at having the first working group meeting in the second week of January, having some draft metrics by spring, and then pushing this out for purchaser implementation in the summer or fall of next year. So just to give you an idea, I think that there is some overlap both in cloud services here and also the work that we do in HPC and the work that we do in enterprise data centers, which is that there are a lot of metrics out there, and there are a lot of metrics that are really good for some things, but may be flawed for particular reasons. So GEC is interested in looking at what is available that we can use. What are the limitations of those metrics? Are there metrics we really shouldn't use because the limitations are too severe? And not only looking at climate impacts, as you can see on the left-hand side of this slide, but also the broader sustainability impacts, such as economic and social impacts, such as workforce rights, community engagement, as well as traditional environmental impacts. So these are just what GEC has pulled together for consideration. This is not a guarantee of what might be in the metrics or what should be in the metrics. Something that GEC is very good at is doing initial research so that they can come to the table with something for people to respond to, which I think many of us can appreciate. It's much easier to respond to something than to come up with something from scratch. But GEC has always been very good about engaging stakeholders on what actually makes sense, and they certainly are not beholden to any of these. These are just things that they think that we should consider. So that being said, there's a couple of frequently asked questions that they also included. I wanted to highlight two things. One is that the development of these metrics are not part of the EP eco label. So they are not going to be connected, for instance, to the eco label for servers or anything along those lines, although they may reference that if it seems appropriate for as a metric for a cloud provider. The other thing I wanted to point out, because GEC is well known for their eco label, they are not intending on certifying, registering, assessing cloud providers themselves. So they will not be slapping a label on cloud providers and saying that they're acceptable. Their only purpose in this initiative is to develop a common set of metrics that everyone agrees are reasonable and that purchasers can use. And then they will go forth and market those metrics to purchasers for use on their own, but there won't be any label associated with it. So I will be on that working group. A number of my DOE colleagues will also I strongly encourage you to participate if this is something for which you find interesting, or if you could lend your expertise. I know that developing metrics for data centers is particularly difficult. You know, we've all been working on that space for a long time. But it is extraordinarily helpful for purchasers who don't have this expertise to have something that they can rely on and which they know providers have agreed are reasonable metrics. And at the end of the day, if we want to have an impact, we really need to make sure that non-IT people are able to understand what it is we're trying to get at. And given the impact of the electronic sector in data centers, I think that's an imperative. So thank you very much. I'll open it up to questions if there are any. Let me see.
Do we have any questions? You're getting some great job and very interesting comments in the chat, but not very much questions.
No
So do we have any questions for Kate? Otherwise, I might have a question. You say that this is a global initiative.
Yes.
So I'm from Europe. Do you have any more people from Europe or other parts of the world, or is it just a US?
No, it is definitely global. In fact, GEC used to be the Green Electronics Council, but they specifically changed their name to Global. Their EP Eco label is used internationally, and their intention is for this initiative to be international. So everyone is welcome to join.
In the beginning, when you talked about the US government's, I think, sort of goals, you talked about that you like to also influence the energy use or carbon dioxide usage abroad. Is that just by the procurements, or is it sort of some other means of that?
That is a good question. I'd have to dig into the World Economic Forum report. It's a lengthy report. I do have the citation in my slides.
Yeah, you mentioned that in the beginning. It's quite an interesting goal to be able to sort of change what other countries are doing as well. So I was a little bit impressed about that, but you don't know so much more about it, right?
I don't offhand, no.
Sorry for bringing it up.
No, it's fine. I understand, you know, there's a lot of work in this space that is coming up to speed. I think obviously as people better grapple with the idea of climate change and resilience and where can we really have an impact. So I know this isn't the only initiative, and this certainly isn't the only work being done. So I would encourage you to participate in any similar initiatives, because I think that it really is important that our expertise be lent to the groups that are working in these spaces.
So there is a comment from about Kate, the ethics in HPC BOF talked about HPC power consumption. Perhaps a mutual beneficial discussion is suggested by Randy. And then we get a question from Eric here. Is the working group metric intended for cloud only or for all data centers? That is a good question.
Yeah, so the work that GEC is doing is just for cloud providers, in recognition that that's something that procurers are really struggling with. That being said, the US government is also looking at the metrics that we are using to measure our data center, our enterprise data centers, as well as our HPC data centers. So there will be some internal federal government work being done in that space.
So I think we need to thank Kate now and see if there might be room for additional question at the end. So the next speaker, thank you so much. And the next speaker is Esa Heiskanen from Finland, CSC. He'll be talking about the LUMI project and how they have been working with sustainability in that project. So Esa, are you prepared to go?
Yes, I'm good to go.
Please,
Let me
go
just
ahead.
share my screen.
Excellent.
Is it visible?
It's excellent.
Okay, great. So my name is Esa Heiskanen and I'm data center operations specialist in LUMI computing facility, Kajaani, Finland. I'm working for CSC IT Center for Science. I have been working on CSC in the data center operations specialist. First, I came to CSC in 2014, and now past few years, I will be working on this LUMI data center project and data center construction work. So as we all know that data centers are consuming more and more electricity during this decade, and that will increase the CO2 emissions also in the old data center area. So that's increasing of DC data center CO2 emissions will be huge in this decade, and we need to probably act now to get CO2 emissions on data lower. This chart is an expected case projection from Andreas Andrae, a specialist in sustainable IT. In his best case scenario, IT grows only to 8% of total electricity demand by 2030 rather than 21%. So currently data centers are consuming more than 2% of both electricity. And what we can do and take a consideration for HPC system carbon footprint. So we have a data center level choices. What power we use, where we buy our electricity, is it renewable or are we using the power that is increasingly generating a CO2 emissions, and also how efficiently our power is used. And there is also things that came in the discussion with this LUMI projects about waste heat reusing. And while we are quite a north in the Finland, we have a district heating already in use, so it was the obvious choice that we will use the LUMI's waste heat to support the local district heating company. And also the construction and retrofitting on the data center, you need to take consider about doing the greenfield or brownfield or something hybrid on both of these. So it's not necessarily wise to always build a whole new building for the data center. And also choices can be done in system level, ICT manufacturing, eco-efficiency of your hardware and software, as known as science per watt. So here is case study about LUMI Kajaani in Finland, what we have done. LUMI will be an HP Cray-X supercomputer manufactured by Hewlett-Packard Enterprise. And the first phase of LUMI has been installed during this year. And second phase of LUMI, the GPU partition will be installed next year. And as November top 500 list showed again that Fugaku was still fastest computer with 513 petaflops, and second fastest was the Summit in USA with 200 petaflops, but I think that there is more faster computers coming next year also. So LUMI is running with consortium of 10 countries with strong national HPC centers. The LUMI consortium countries are Finland, Belgium, Czech Republic, Denmark, Estonia, Iceland, Norway, Poland, Sweden, and Switzerland. And LUMI will be one of the world's best known scientific instruments for its lifespan when it's fully operated. And this is where we installed our next supercomputer in Finland. This is home of Lumi. It's a reinforced around the business park located in Kajaani, Finland. This is an old paper mill site that announced in 2008 to shut down the paper mill production in Kajaani. It took about 2 years to transform this old paper mill industry area to modern business park and data center park. And CSC's national HPC data center has moved to Kajaani in 2012. We have a local district heat plant in the area, and this is the building that Lumi is now installed. So as you can see that we have a demand for district heating very close on our data center, so waste heat usage is very efficient in this area. There is also in the area very stable and good network for electricity. When the paper mill was running, the total energy consumed in the area was at top, I think, 240 megawatts. So there is still plenty of room for data centers. So we have a high capacity green power in the area, provided with 6 link to the national grid and delivered on the area from the new distribution center, which was renewed a year ago. There is a lot of green energy production in the region, including 3 local hydro plants, solar power, and wind farms. So Lumi uses 100% certified hydropower with carbon usage effectiveness of close to 0 in all the data center production and office environment in Kajaani DC area. And there is green power now available up to 200 megawatts in this area.
Did you mention the power consumption by Lumi system itself?
Lumi itself is about 10 megawatts. Design basis is for 10 megawatts for IT.
Good, thank you.
And this is some calculation from Schneider Electric white paper, benefits of the brownfield solution. So we built a building inside an old paper mill factory hall, which lowered our usage of concrete and other building made materials lots. And we are assuming that we have reduced our CO2 footprint of Lumi data center construction by over 80% with the brownfield solution versus construction on all new building for the Lumi. 95% of Lumi is directly cooled waste heat can be reused in the district heating system of Kajaani. This will lower energy cost down to 37% as local energy company pays for the waste heat. And as an alternative, there is also a lot of free cooling available because of the climate on the northern Finland is quite a cold. With the Lumi's heat, local energy company can reduce the use of oil that corresponds in CO2 emissions to removal of 3,000 cars from the traffic. So it's minus 13,500 tons of CO2 emissions. And Lumi will produce 20% of Kajaani district heating needs when it's in fully operational. In Kajaani, there lives about 35,000 persons, so that's the size of the city, but still we can do up to 10 megawatts of district heat, and it will generate this much of CO2 emission benefits.
But basically, the city of Kajaani is needing 50 megawatt of heating in the winter?
Yes, it is. We have currently minus 25 degrees in here. So district heating has been used in this area at a long time, so there is an infra that is ready for it. So we just had to do a 200 meters of pipe to get connected into it. So that's a benefit in this area. And this shows the basic principle of how we do our cooling for the HPC DLC load, and it's approximately 9 megawatt will be HPC load on the Lumi data center. Then we are using the heat pumps, and heat pump evaporators will raise the outlet water from Lumi to 80 Celsius degrees to get it suitable for district heating. And benefits of this area is that local district heating plant is near, and we can directly use all the waste energy that is generated in the DLC partition of the LUMI. And also we have a dry cooling for a backup, so we can use the free cooling if we have some problems with the heat pump production. So in the LUMI system level, we have made choices about ICT equipment life cycle, is responsibility and sustainability required and rewarded in the CFD. Operations and energy efficiency, chosen GPU solution and LUMI will be at top of Green 500 over multiple lists. Other considerations that have taken into account, LUMI is strongly positioned as an instrument for climate research, especially EU's Destination Earth program, which is the climate adaptation to Gildat Wind will provide vital insight for how to mitigate the climate change. So, concluding remarks of what we have found out. Carbon footprint of ICT, HPCs included, does really matter. Greenness of the HPC installation is fully dependent of the data center level choices, especially contracted source of energy. HPC system do not need to be physically located in the country where it's being used or who owns it. Carbon need neutral, even negative HPC operations possible already today. Use 100% carbon neutral renewable energy, wind, nuclear, solar or hydro. Reuse the excess heat. It's big amount of energy wasted in yearly basis during the HPC operations. And repurpose existing buildings and use the brownfield solutions instead of building all new DCs if it's possible. So that's pretty much what I had on my mind today, and here is my contact details. So feel free to contact me if you want to have a discussions or know more about this, what we have done.
Okay, so we have thank you, Esa. We have a couple of questions. So okay. Herbert Huber asks about what is the outlet temperature of LUMI? Do you need a heat pump to be able to connect it to the district heating system?
Yes, the estimated outlet will be about 32 degrees inlet, 44 outlet, and so we need to use the heat pump to take that outlet water from the heat pump up to 80 degrees, so it will be suitable for the district heating network. If you are doing, for example, warming up the buildings that are located in the same area, then it's not necessarily needed. You can drive, for example, for direct building heating with the lower outlet waters, but did you get the answer?
I think it was pretty clear, yes. Okay. David Grant is also asking about the manufacture of those heat pumps. How is it possible to generate 80 Celsius output?
Klima Veneta and Mitsubishi usually builds these kind of heat pumps. So other side, in the evaporator side, they are doing cooling, and on the condenser side, otherwise, in the condenser side, you are doing the cooling with the pump, and on the evaporator side, you are heating up the other loop of water with the existing energy, and of course you need to use some energy, but COP value of this kind of a heat pump is close to 4, so every megawatt used for electricity can produce 4 megawatts of heat.
Quite impressive. So there is also a question about if there is potential impact on the local wildlife in the area.
I don't think so. We have of course there's a wildlife in the area, but I don't see that how the HPC DC would impact on that.
So there is also another question. I mean, this talk was extremely interesting, so it generated a lot of questions. So except for the Schneider paper, is it are you aware of any calculators analysis methods to evaluate embodied carbon on new or existing buildings?
I haven't been involved in the other calculations or analysis, but I would be interested if someone has knowledge about that kind of analysis that has been done.
So I had the questions for your table where you had the different kind of carbon sources, and you also had a negative source there. Can you explain that again?
Yeah, if we are buying 100% carbon neutral energy, for example, water, some renewable energy, for example, wind, and then we are using the waste heat that would be driven in the roof. So we are using the waste heat to generate up energy that local energy company is buying. So maybe we can claim to be as negative carbon footprint. And because this local power plant is using lot of fossil fuels to do the heating during the winter, so everything that can be lowered usage of those fossil fuels, it would be better for the environment.
So do we have any additional questions to Esa at this point? I don't think so. Could you share specifics as to how is ICT equipment life cycle included in the?
I can check that thing tomorrow and come back to you, Natalie, with this.
Okay, I think that was the last question, and we should thank Esa for talking to us today. I know that this is the Independence Day of Finland, which is meaning quite big celebrations there. So yes. Thank you very much for coming to us anyway. So that's really an achievement. Thank you so much.
Thank you.
Natalie, do you like to say some concluding remarks or?
I think Sid is prepared to do that. Thank you.
Okay, please, Sid.
Yeah, thanks, Gert. This is a very interesting set of talks. Folks, so agenda for tomorrow, we have 2 sessions, one on liquid cooling and one on system-wide power monitoring challenges and current approaches.
I'm gonna go run some errands, but I'm gonna take the truck so I can drop off stuff.
If others on the call could please mute. Just one last comment. Please note that there's a different meeting link labeled as day 2. It should be on your calendar invites. So please look into that. Closing thoughts, really, the workshop website has links to all the presentation materials. This meeting is being recorded, and hopefully the chat logs are also being stored somewhere. And really, on behalf of Torsten and I'd really like to, Torsten definitely, I'm sure, would concur. We've really been quite thankful of contribution from all the workshop organizers here. So big thank you for that. Torsten, any other closing thoughts?
Oh, perfect. I really liked that day. That was very interesting talks and discussions. Thanks everybody for participating.
Yep. Thank you all. Thanks.
Okay. See you tomorrow, all of you. Thank you. Bye-bye.
Yep. Bye.
Bye-bye.
Goodbye.
Bye.
Thanks.